start fine-tuning with Tortoise today. For those of you unaware, Tortoise is an animal, but also it's a TTS system, text-to-speech system that's developed by a person named Neon BJB. Um, it seems to be really decent in what it's designed to do, and so far we couldn't fine-tune it, but with recent developments the possibility is now available. So I thought about I'll showcase just a general workflow. I do want to preface it that this is really early days for fine-tuning the system. Pretty much everything that I'll show here is bound to change through even day by day. So don't take anything here as gospel outside of just the general workflow of how you can do it today with your GPU. My system is running a 4090, but I believe you can even train it on 2060, depending on the amount of data that you have. I will be demonstrating fine-tuning a small data set, and when I say small, I mean I pretty much have just this one file of Fadrigas Cohen from Bloodborne, and it's 2 minutes long, and you can't hear it, but it's basically Fadrigas Cohen's voice lines into like on one file. So we'll start by actually creating the data set that you need for the trainer, and for that I made a separate tool that's called Ozen Toolkit. You can just grab it from the GitHub. I'll link it down here. So let's set up this tool first, and then we can start working. But do note that you will need to go into Hugging Face and in this address and accept the license terms, and you will also need to install Anaconda if you don't have it already. And that's it. You just need to clone it, and we have the bat file. So let's start by setting up the environment for Ozen. And I designed some of this stuff to be as simple as it can be to install. This is aimed at obviously Windows users, but I presume Linux users can pretty much make use of this as well using the different terminal options. You guys, I don't believe really need any extreme types of, user friendliness usually, because Linux people are usually tech savvy as it is. But I designed it to be used by the common people, as you might like just somebody that wants to dip his toes into it without a lot of commitment and starting to get into like really nitty and gritty stuff. So I'll stop the recording at this time. I'll let it install. It'll basically just set up the environment for us, and it will download everything we need to run Ozen. I will not be showcasing Ozen's configuration, but it's pretty simple and it will be kind of guided. The way you use the tool, as I'll show, is you just drag the file on the drag here command, or you can drag a folder to process the folder, and the folder needs to have obviously sound files, and Ozen will take it from there. But if it's the first time that you are booting up Ozen, you will be asked to provide a Hugging Face token connected to the account where you accepted the license terms. This is to use the model that is gated and is used to segment the file into different parts for us to use in the trainer. So I'll stop for now, and we'll pick it back up soon. We can just start processing the file that we want. For this tutorial, like I said, I'm going to showcase Father Gascoigne from Bloodborne. And to get started, all you need to do is just drag your file on the drag here, and it will boot up and start working. So what it's going to do is look for gaps in the speech to determine where to split the files. It will then split them and transcribe them using OpenAI's new speech-to-text model called Whisper. It's fairly accurate. I advise that you obviously check the outputs afterwards, um, but for most stuff, for most common words, it performs really well actually. So you might just have to go and change some names or stuff like that. So as you can see, we got 13 files out of this small file, and these are like between 2 seconds to 12 seconds long, and that's good for our training. And it's done because again it's a small file. And under outputs we'll have the Fabregas coin folder, and we have this structure. You'll notice that we have train and validation. Basically, every dataset that you create will have a certain amount of files that you're actually training, the trainer will see and try to optimize for, and you have a validation set, which is the trainer checks against them to see if we're hitting what we expect to hit. Inside the WAVs folder, we have obviously the sound files, and this folder is basically what we're going to input into our trainer. So we're going to be training with DL Art School by 152, I don't know. And it's a new trainer that just came out. Again, we're using like really bleeding edge stuff here, but you can just git clone this, and once you do, you will have your folder, and inside this folder what you want to do is press the setup DLAS bat. And similar to Ozen, it will create an environment for you. It will download everything that's necessary and set it up so we can actually start training as fast as possible. It's going to take a few minutes. So again, I'm going to stop the recording here, and then we can actually show you how to train using the dataset we just created. Done. It will download all the model files that you need and everything, and you'll be ready to go. Just select the start DLAS command, and you will be greeted with the UI. Right now I already have a config loaded here for a previous training session. When you finish training session or you just start it, it will get saved, and you can just return if you want to rerun, change some settings, and check other options. So let's go over the options real quickly. Project name, self-explanatory. It will determine the project name for the training. GPU IDs, you can set your GPU IDs for distributed training. This is untested currently. Enable gradient checkpointing is a way to save on VRAM. You should leave it on. FP16 is to train with mixed precision, and it's usually good for stuff like stable diffusion. I never tested it in Tortoise, so I don't suggest you do it on your first run. And by the way, you can also just hover over the options to see some information on them. Use TB logger is the logger that we'll be using to actually look at our training and how it's going, and I will showcase it soon. And under the data settings, we can specify the data set we just created. So I'll just select the folder, and keep in mind that you can, like if I would put some really weird values here, I can just press other settings and it will snap back to what's actually possible. In this instance, the batch size that I put is higher than the actual samples that I have in the dataset, so it's being snapped back so we can actually utilize everything and not run into bugs with the trainer. Under steps, you can, this is actually kind of disingenuous, this is kind of like epochs more, but we'll call it steps for now. And I set it for my training session for this data set, which is really small, to 200. Again, all the values that you see here are about to change. This is just stuff that I tested, and they're not necessarily correct. So take it with a grain of salt, experiment, but that's what I'm going to be setting it for now. Warm-up steps, -1 means basically it won't use the warm-up steps. This should be used for larger data sets. I never used it, so I can't tell you how it works. Gradient accumulation steps, also a great way to save on VRAM. You can leave it at 4. Keep in mind that if your batch size is, or the amount of samples that you're training is lower than that, you'll run into issues. So set it to 1 or 2, depending on the batch sizes. Learning rate, this is what's currently being advised on, so I'm gonna leave it at that. And the learning rate stepping is basically how the learning rate is going to be decayed throughout the training session. These are the numbers that I'm currently using, which I found that work well for me, but your mileage may vary. EMA model is something that might be used later for the diffusion model training, but for the GPT one, which is what we're going to be training on, it's actually not doing anything. It will just save double checkpoints of a model that's unusable, so I checked that off. Save states is basically a file that gets saved alongside a checkpoint, and then you can resume training. So if you have a large data set and you're doing a large training run, you might want to have this on so you can generate states so you can resume the training from. In my case, I don't want them because I'm not planning, this is a really small data set. This is like a one-shot voice cloning stuff, so I don't want to do that. I just want to be saving the space, because these files can get pretty heavy really quickly. It's like 4 gigabytes for one file. So I'll set that to off. Training seed, you can just keep it on this one if you want to have deterministic training. And the print status frequency is what's going to be printed on the console, but it's also going to affect what's printed in TensorBoard. For this training session, I'll keep it at 10. Save checkpoint frequency, again, I'm going to leave it to 10. I'm expecting it to be 200 steps, so it's going to be around 20 gigabytes at the end, which I'm fine with it. Visual debug frequency is kind of broken right now, but it's supposed to output images at some point. I just put it to 500 because it's not really working anyway, so I don't really care about it. So yeah, we also have advanced settings, and these stuff, if you don't know what you're doing, just don't touch them. They're pretty much just set up to be used this way. And you will notice that we have an update available button. You can use that to automatically update this Git if there's a new update published. If not, it won't be there. So you won't see, so don't be alarmed if you don't see it. It's just because I'm not using the latest one. Yeah, and this is the playground where we can actually test our model, and I'll showcase that after we train it. So let's press start training, and once we do, the UI will disappear, and we can see in this console we'll start getting different stuff being printed as the trainer is booting up, and it will give you the configuration and everything, and it will start processing our data set. As you can see, it's starting to train. So we want to actually see what's going on in the training, and this is kind of important to understand. We want to get the best idea of what's going to happen, as opposed to something like stable diffusion. We don't really have currently a way to sample it during training, so we want to observe the losses or the mistakes of the model is doing. And to do that, we'll be using TensorBoard. So we can just use this start training monitor, and it will open up a new window, and it will take the latest experiment, the training session, and find it automatically. We can just input it here, and we get this console. And the main two ones that we are looking at are these two, and the aim is to get them as low as possible. So I'll let it run now for the 200 epochs. I believe it will be something like 10 minutes, something like that, so I'm not going to be recording, but when we finish I'll show you the graph, how it looks, and how to pick up checkpoint if there's anyone that kind of looks better than the rest. Right. We finished training, and we have the curve here, and as you can see it's going down nice and steady, and we finished when it's really low, and which is exactly what we want to see. I'm not a professional, I'm just a hobbyist. As far as I can tell, this is like the loss going down is what we want to see when we're actually training. It means that the model is running what we're giving it, and the validation is being met with this amount of errors. So if we go back to the trainer, we can actually play around with the model. So we'll open up the UI and we'll press the playground option. Once we do, it will ask you if you want to actually set it up. It's a separate download and a separate, complete separate Git maintained by the same author. It will just clone it down here automatically for you and install everything that's needed to do inference using Tortoise. So it'll just take a quick minute to do. So as you can see, I ran into an error, and this sometimes happens, but it happens to me mostly because I keep installing and reinstalling and stuff like that. The way I found to fix it is to go down here and delete the Tortoise folder. Seems like it's just a refresh issue. And I'll also delete the results folder, which gets created when we actually install Tortoise. And I'll press it again. Normally you shouldn't run into this issue. Again, it's just because I keep installing and reinstalling the environment to make sure that everything is working properly. So my conda is kind of backed out at this point. But this is how you deal with it if you do meet this issue. Alright, so because again my environment is kind of fudged all over, I get these yellow warnings, but it's fine, it will work. And we'll start the UI again. And now we can actually use the playground. And when you actually click it, it will load the latest model into memory. So we'll give it a second. Loading the model into the memory will allow us to actually do inference faster. And Tortoise is aptly named. It's kind of slow, and we want to be as fast as possible when actually doing inference. So we're loading the model beforehand. So as you can see, it already found the latest model, the latest checkpoint that we would put, and we have a few options here. The text that you want to test on, the seed. This is great if you want to reproduce the same seed across different checkpoints. Quality candidates is the amount of audio files it will create for you that are possible for you to use. Free is probably a good number to use. Compared to original is an option where it will generate using the settings you provide with the fine-tuned model and the original model as a way to actually compare how the changes have taken place. And use string data as voice. If you're not aware, Tortoise is using voice conditioning, so you give it like a few sound files of the speaker that you want to emulate, and you can try to emulate it if it has the data inside the model. Since we fine-tune the data we want in, we can just use the same training data to create the conditioning, and that's what I have it set in. But if you want to specify a different speaker or whatever, you can just put the directory path here, it will get loaded instead. So let's look for stuff Father Gascon will actually say, because why not? And let's use this quote. I will put down a seed of just a simple one, and that's because I want to compare to the original. I did find that on fine-tuned models especially, and that is maybe due to the low amount of samples that I actually trained on, but I get distortion if I use the simpler presets. It exists also on the non-fine-tuned model, but lesser to some extent. So what I like to do is keep it on standard. It will take a bit more time to generate, and but the result will probably be a lot more usable. So we'll hit generate, and once we do, we will actually start creating and sampling from the fine-tuned model. Since we set it to compare to original, it will also sample the original file. So right now it said could not find training data directory, and that's because apparently the way it tries to find the data is through the YAM, the configuration files, and probably I deleted by mistake at some point, and so we'll just specify it ourselves. So we'll go back to our data set and have it down here. We'll take the webs and we'll just put it here and hit generate. And now that it has the voice candidates, the voice conditioning files, it will actually generate. So let's see what it does. So I'm gonna pause the recording here while it generates our audio, and we'll pick it back up. And again, this is just a small training session using a very bad data set, so keep this in mind. But as you can see, we have an original webs and just webs. Webs is the fine-tuned model, and the original is the original model. And let's see.
What's that smell? The sweet blood. Oh, it sings to me.
So as you can see, there's been some issues with the original model and this voice on this particular seed. And on the fine-tuned one.
What's that smell? The sweet blood. Oh, it sings to me. It's enough to make a man sick.
Yeah, so it seems the fine-tuned model is definitely takes the character a bit more into account than the way it talks from the training data. And again, this was a really small training session. Everything is very experimental. There's still work to be done on training the other models in the stack to get the quality up and try to get the best training parameters. So again, if you want to contribute to the project, or you want to just come and chat, or you have some issues, I'll leave the GitHub links for Ozen and the trainer down in the description. And there's also um, training notes, and like I said, this is very experimental and still being worked on, so um, 152 is actually has a few threads where he talks about his experiments and what he learns from them, and I try to share what I I test as well. Some people are trying to do non-English models, which seem to be working to some extent. I never tried it myself, but an interesting topic for research. So you want to give it a go. This is how you do it. And right, see ya.